Am I late? I'm sitting there texting, just like you guys. Hi, everybody. How you doing? Time got away from me. Everybody doing okay? Who's on today? Look at you guys. Io, I didn't know you existed. Wow. Hold on a second. Mrs. Snow is calling. All right. Okay, so here's what I want you to do. Okay, a couple people were asking some questions, and then we'll talk about what the assignment is for today. So get your either you could do online or get your PDF version right here. Okay, get your PDF if you printed it out, or get that if you want to do it online. You can look up these problems, but people were asking about some of these questions, so let's talk about them first while people are getting on, and then we'll talk about the assignment. Somebody we were talking number 12. Let's go to number 12. Let's start with that. Hope everybody's doing okay. Here's number 12. Got my stuff here. All right, take a look. He's got to go walk around the halls for a while, so he's just wearing a path of the halls in his house right now. Okay, we got the number of gallons is by this equation. So they gave us an equation here. Okay, 25 minus t squared. Okay? At what rate, gallons per minute, again, units always give it away, gallons per minute, is the tank changing? Okay, so they're talking about at what rate is things changing. Okay, so this formula is the number of gallons in the storage tank. So how do we find the rate? We find W prime of t. There's the rate. We take the derivative. We get negative 2t. Okay. At what rate is the amount of water in this tank changing? Well, plug in our 3, and we get negative 6. Take a look at that one. That was number 12. And then, so I forgot, I just wrote down which ones people were asking about. So if you were stuck on that one. But it's really just a translating one. It's the verbs. It's translating what things are saying right there. Okay, so for example, if I'm looking here, look on that spot right there. I know when y equals 4, the slope should be 0. So that's the first thing I'm going to check. When y is equal to 4, the slope is 0. Oh, well, wait a minute. That didn't help me any. Because anytime I plug in y is equal, that's going to be 0, 0, 0, 0. So the thing we're looking at is the beginning part of that. Okay, so now what else do I know? So there's another 0. Okay, when y equals 0, the slope should be 0. You see that? So now I know when y is equal to 0, the slope should be 0. Well, right here, doesn't, yes, yes, yes. So at least I got rid of that one. When y is equal to 0. You see that? You see how I'm eliminating stuff? Just process elimination right there. So now I say, all right, what about when x is equal to 0? When x is equal to 0, this one's supposed to be 0 also. Well, wait a minute. When x is equal to 0, all the slopes are not 0. So it can't be this one. Also, remember what we said. If the look across and look up and down, these are all the same. No matter where I look, they're all the same going across. So that means x should not be in the equation at all. So that's another excuse for A and C to be eliminated. So now I'm working on B and D. Now, how do I pay attention to B and D? Well, the square. The square is the difference there. What does square do? Square makes everything positive. Okay? So in this situation, no matter what the y is, this is positive. And then I go to the parentheses, and this is positive when y is less than 4, but negative when y is greater than 4. So we're going to look at the positives and negatives here. So let's pick a point. When y, let's say when y is 1. When y is 1, let's do 1 just to show an example. I plug in 1 there, and I plug in 1 there. I should get a positive slope. When y is 1, yep, I get a positive slope. Okay, same thing here. When y is 1, I get a positive slope. Now let's pick a negative slope. When y is negative 1, this should produce a positive number. And when y is negative 1, this should produce a negative number. You see what I mean? At negative 1. So there's my contradiction between those. So let's see what happens. When y is negative 1, all these slopes are positive. So it has to be this one right there. It's just a process of elimination. Look at some of the tricks that we used here. One, B and D now. Now if we're looking at B and D, the big thing is the square. And what does square do? It gets rid of the positives and stuff. Okay? So we said, oh, look at all these slopes are positive right here. Okay, so that has to be this one. I get another one. Where are the slopes negative? The slopes are negative above 4. Take a look at the graph. See how these slopes are all negative above 4. So when y is, say, 5, we better get a negative number. Okay, well, when y is 5, this one takes over. You see that? That's why I focused on the square and the not square. It's just really just a process of elimination on these slope fields. Is that okay for everybody? Let me know in the comments if you still want to talk about that one. If you don't let it go, like always, just like in class. If you're still confused, someone asked about 17. If you're still confused, we should talk about that. All right, so 17, we got a particle moving. We got the position right here, the position of the particle. What's the velocity? Okay, find the first time at which the velocity of the particle is 0. Well, how do we get to velocity if we have position? Okay, if we have position and we want to get to velocity, we got to take the derivative. Okay, here's our function. Let me write a little bigger. 12e to the negative t times sine of t. So hopefully, to find the velocity, we take the derivative of position. You see that? Now, how are we going to take this derivative? Oh, we got a product here. We got to do product rule. Okay, so x prime of t. Let's do product rule. To derivative of the first. Here's a keep. So chain rule gets a negative 1 right there. Derivative of the first times the second plus derivative of the second. What's derivative of sine? Times the first. There's product rule right there. You see that? And now we plug in. First time, okay, find the time. We're going to solve for this when the velocity is equal to 0. So I'm going to set that equal to 0. 12e to the negative t, negative sine of t, plus 12e to negative t cosine of t. Okay, now here comes you got to remember our algebra 2 here. Okay, I'm going to factor out a 12. I'm going to factor out an e to the negative t. And I get negative sine of t plus cosine of t. So either 0 is equal to that, and hopefully you recognize 0 can never be an exponent. 0 equals 12e to negative t, which cannot happen. Exponentials always are above the x-axis. Remember that? Remember what the graph of e to the x looks like? Or 0 equals negative sine of t plus cosine of t. Now you're saying, without a calculator, how am I going to solve that? Remember, that was a little trick one. Where is sine equal to cosine? If I add sine to that side, where is sine equal to cosine? And it's no calculator, so you should be thinking to yourself, it's got to be 45, 45, 90, or 30, 60, 90. And so which one is sine and cosine the same? 45, 45, 90. Okay, so the first time they're the same, that's why it's A. So notice it's got to be an over 4 one. 45, 45, 90. How's that? That's a tough one. That's a tough one. That's not as straightforward one. We had to do product rule. We had to solve when it's equal to 0. You see that? I had to solve that. So we factored out, and you got to recognize that that is never 0. Now, maybe you didn't recognize that, and you start solving it. You divide by 12. You take natural log of both sides. Well, right there, you're taking the natural log of 0. You got to see, can't take the natural log of 0. So you got to figure that. That's a lot of little situations right there that you got to pay attention to. Okay? Does that make sense? No one's saying anything, so I'm thinking we're feeling pretty good there. Number 16. People are saying number 16. Let's look at 16 while we're on the page. We got a function. We want concave up and increasing. All right, let's translate. What does it mean to be concave up? What does it mean to be increasing? Okay. Increasing is the first derivative. Increasing, remember, we've got to use our synonyms. The function is increasing means the first derivative is positive. The function is concave up means the second derivative is positive. You see that? First derivative is positive, second derivative is positive. So what do we got? Let's find the first derivative. F prime of x, pretty straightforward. 12x minus 6x squared. See where it's equal to 0. Remember, you're not looking for positives and negatives. You're looking for where it's equal to 0. Factor out of 6x. We got 2x, or 2 minus x. So we've got 0. Here's our number line. And 2. You see what I mean? And let's plug in a number. How about 1? Plug in 1. Positive. How about plug in 3? Negative. How about plug in negative 1? Negative. So 0 to 2. How's that looking? Everybody okay there? Then I go to second derivative. 12 minus 12x. Again, pretty straightforward solve. Hopefully pretty obvious. X is 1. Check this side. Plug in 5. I get a negative. This side I plug in, negative 2. I get a positive, so this is positive. So here's the question. Where is it concave up and increasing? Where the second derivative is positive and the first derivative is positive. Where does that go? Only between 0 to 1 is when both of those situations happen. So the answer is between 0 and 1 there. How's that? We good there? All right. While you're thinking about that one, let me talk about what we want to do. Stephanie had a good suggestion. Okay, take a look. What I posted, if you looked on Schoology before it goes down again, take a look on Schoology. Get it now before Schoology crashes. Here I put the objectives in the week 1 e-learning. Okay, and remember, we go through 1 through 7. Okay, so what I want you to do is I want you to print off those objectives, grab those objectives, and get your binder out. Okay, this is your assignment for today. Okay, get those objectives, get your binder out, and look through each one of them. Read through each one of them. And find it in your binder. Because here's what I'm really thinking. We'll have more official notes tomorrow. The AP is really coming out with a post tomorrow, they said. But what I'm thinking is going to happen is your AP test is going to be open notes with calculator, free response questions. And they're probably going to give you like an hour window to submit it. Okay? And so you have to be ready to go. It'll be online. You log on and do whatever you need to do. And they'll probably have a test day or a test to make sure your system's working, whatever. But you're not going to have time to fumble around with all your notes. You've got to be organized. Okay, so what I want you to do is get your binder out. If you've been following along with that binder, you should be pretty organized. But remember, we wrote in those binders all the little tricks, all the little things to pay attention to when we come across an idea. So what I want you to do is in your binder, here's where you get your tabs out, get organized, and find in your binder. Read through this and find these spots and organize them. These are the 8 objectives to Chapter 7, Unit 7. We don't do Unit 8, remember, that they took that off the test. Okay, so, and then remember, this, if it's grayed out, this is BC only. So you don't have to do those either. So look in your binder, make sure you have every one of these things tabbed and ready to go. So if you recognize the problem, this is a question about discontinuity, I go right to that discontinuity, and then you see all your little hints of what you need to do there. Okay, so what I want you to do is work through that and then post on Schoology or post here. Okay, post here, post on Schoology. Okay, and then post which ones we want to talk about. Which ones you're like, yeah, I'm not, that doesn't look very well to me. Let's go over that one again. Find something. Yeah, just when you're telling me, the easiest thing to do is just say, hey, on unit 1.14. Okay, and I'll look, 1.14 is about talking about limits and vertical asymptotes. And so I'll say, all right, here's the one we're going to work on. And if it takes us 2-3 days to go over this, it takes us 2-3 days. But what you want to do is you just tell me, organize your binder any way you want, but you got to find it when you're taking the AP test. Okay, so if we're talking product rule, you say, Mr. I can't find my notes on product rule. Then we'll go over and we'll do the notes on product rule. Okay, we don't want to use all this time to, go over every single topic. I'm sure you know most of the topics already, but there'll be some of them that you're like, what was that? What was that big trick that we used to do? I didn't get it written down because I'm lazy and I didn't pay attention to you in class, Mr. Noah, about solving optimization problems. Okay, so you got to find all that organized, and then we'll say, here's the little hints, here's the little tricks, here's the little thing that you should have written down on that section. And we'll be going over that more as we go through some more AP type problems. But I want you to get organized on that because it looks like the AP is going to be with calculator and with notes. So might as well have them ready to go and ready to put out. Does that make sense to everybody? Is that okay? Are you understanding what the idea I'm trying to get across that I want you to do today and tomorrow? And just give me post some, whether post on Schoology or post it in the comments here, because YouTube's not going down, and I know you watch YouTube. Does this make sense? All right, so then there's a couple more problems I want to do, and then I'll have at you going to that. Take a look. Just a few more problems that we didn't cover yet. Were you able to work on the with calculator ones? On that, whether you did it on the actual test online or whether you did it online or whether you did it in on the PDF that I put on there, if you're able to do that. But there's a couple ones that a few people got wrong. Stephanie says, I will make a group chat. Oh, see, that's nice, Stephanie. What a leader. Let's take a look at... Yes, they would be interested, Stephanie. Who's not saying they're interested in trying to be successful? Take a look at the results. Let me pull that up here. Oops. Hold on. I messed up here. All right. Results. Everybody should be interested. Okay. Were you able to go through the with calculator ones? Because there's a few that people had a little trouble with. For example, everybody look at number of with calculator. Let's go through that one. Everybody take a look at number 80. If it's on the PDF, if you're following along online. Okay. Look on. Okay, look on. Take a look over there. Number it's 82. Okay, it's 82 on the PDF. Okay, but it's 37 online tests. Okay, take a look at those. Okay, everybody with me? All right, take a look. Where is the... All right, take a look at the document. This is 82. And a lot of people got this one wrong. Okay, this is kind of a tougher one. There's a lot of work to be done here. Hold on here. Let me find blank sheet. I ran out of blank. Oh no, ran out of blank sheets of paper. All right. So we got the velocity. Okay, this is with calculator. Okay. Everybody with me? And then we got hold on. My stream is not. Is the stream cutting out to everybody? It seems like it's it seems like the stream's cutting out. Is the stream cutting out to people? Let me see. Yeah, it says it's giving me. It says we're losing bit rates. Yeah, it says there's. Hold on here. Yeah, it's. I just gotta. It was just. I'm reading through. It says there's some frames that are dropping as we're going through it. Okay. Well, let's see. Let's try a few of these problems, and if it drops out, okay, we'll try a few of these and see what happens. Okay. So what we got is we got our velocity. Okay. And this is with calculator. And a lot of people got this one wrong, and it's an easy fix. Okay. We got, I think the big mistake is people went and just did regular distance. Remember, the integral from 0 to 2 of v of t dt, if the integral of that, okay, we got displacement. Okay? That's the displacement. Okay? That's not what this question is asking about. This question is asking about distance. The integral from 0 to 2 absolute value of v of t dt. Okay? That's distance. Get that in your notes. Get that in your binder. Okay? That's distance. Okay? Does that make sense? Put that somewhere in your binder, because what you did is probably, let's take a look at just this with calculator one. Okay. I did have, yes, I entered it in the calculator because I was wondering why everybody's getting this wrong. Take a look inside the calculator. Okay, inside the calculator, you got, and if you just do a regular old integral, take a look at the top one. If you just do the regular integral, that's b. Okay. On a regular integral, and that's why a lot of people picked b, because you just did your straightforward integral. Okay, but that's not what the question is asking. The question is asking for distance. Okay, the distance is the absolute value. You see that? So if you put the absolute value around it, now you get your distance. Look at the two different numbers right there. Okay, a lot of people picked A or B on this one because I'm thinking you just didn't put the absolute value around it. Okay, you want to put the absolute value around it, there's your answer right there. Take a look at that. Just trying a few most missed ones. All right, that seems like it's doing better now. Okay, yeah, it seems like. All right, so that one, and then let's do another one. There was another one on the with calculator one. Take a look at your with calculator. Let's go, how about with calculator? Look at number 42, which would be over here, which would be if you're 42 if you're online, or I believe it would be, let me double check, 42. It looked like this one. It's this one down here, 87 regular. Okay, so 42 if you're online, it's 87 if it's the regular one. Okay, there's a little data one here. Okay, once we got the data, okay, twice differentiable function, which of the following is true? Okay, we have f, we want f prime. Okay, so how do we go from data when you have data and you want to get the derivative? Okay, we're talking mean value theorem. Okay, f is negative and decreasing. Okay, so remember, translation, f prime is negative, meaning f, since we're going back to what we were given here, meaning f is decreasing. F prime is decreasing, meaning f is concave down. You see what I mean? That's the translation. You always want to use your synonyms to translate from one to the other. Okay? So f prime is negative, means f is decreasing. Well, let's take a look. Okay? The numbers? Yeah. The numbers are all decreasing. So I can eliminate C and D right off the bat. So now, how do we talk about increasing? Well, there's where the mean value theorem comes in. Okay, we want to see the rate of change. We want to look at f is decreasing. Let's look at the rate of change of f prime. F prime is minus 5, minus 4, minus 3, minus 2. You see the rate of change if I labeled this f prime of x. Everybody following this? What's going on with f prime? F prime is decreasing also. Okay, does that make sense? The change here, it went down 5. Oh, no, wait, it's increasing. My fault. Increasing. It went down 5, then down 4, and then down 3, and then down 2. Well, the answer has to be B. F prime is negative, but f prime is increasing. You see what I mean? Did that work for everybody? All we did is I used mean value theorem to find the rate of change. Not lucky me, they were all changing by 1, so I didn't have to do rise over run. I just see the change. Negative 5, negative 4, negative 3, negative 2 for f prime. And those numbers are going up, so f prime is increasing. And then I looked at the regular values. Those values are going down, so f prime is negative. How's that? Use the synonyms here. Use our little chart to make your translations. Is this okay? Anybody say anything? No one said anything. We good? Anybody? Those are the two that I wanted to go over, and I give you your assignment. Does anybody have another one before we close off here? Anybody have another one that they still were stuck on? You could always post that, but these are the ones that people posted, and it looks like my network is cutting in and out, so I don't want to keep you guys too much longer because I might lose you, and everybody's using the internet now. I don't know why. I'm going to have to restart the computer. I don't know why this is all cutting in and out here. All right, so you have your assignment, and we did some problems. Now remember, we want to, next couple days, I want to go over objectives. I want to get your binder. I want to organize your binder and make sure it's ready to go. And then we'll find out tomorrow what's going on with the AP test. So we'll see exactly, and we'll plan for it. Okay, other than that, what am I going to do? We'll say, what did the ocean say to the shore? Nothing. It just waves. Bye.